Good evening, everyone. I, Balakdas Kurmi, welcomes you all on behalf of ISF College of Pharmacy in the ISFCP Dialogue Series under the Aegis of IQAC and IIC of ISFCP Moga. So today we have Professor Viney Chawla sir as our expert for the day. So welcome you, sir.
Thank you.
Pro- Professor Viney Chawla sir is currently holding the position of Professor and Head, University Institute of Pharmaceutical Science, Baba Farid Health Science, University Faridkot, Punjab. And Professor Viney Chawla sir is the alumni of the College of Pharmacy, New Delhi and Punjab University, Patiala. Sir has held the various positions in different regulatory bodies in the state and central also. And sir had very vast experience on academic as well as research in the field of pharmacy. So hope today's lecture on the topic fluidized uh, dryer and its industrial application will be very useful for the listeners, viewers, and all the pharma students. So I welcome you, sir, on behalf of ISF College of Pharmacy, Moga.
Thank you,
And
sir.
sir, please proceed and over to you, sir.
Thank you so much, Dr. Balakdas Kurmi, for your introduction. As we talk today, I must thank the management and principal of ISF College of Pharmacy for providing me this opportunity to present this lecture in the dialogue series. Topic that I have chosen today is fluidized bed dryer and its applications, specifically in pharmaceutical industries. So this fluidized bed dryer is an equipment which is also known as fluid bed dryer. Among the various types of dryers that are available, we know that there are some which are having a static bed, that is powder bed is not moving. Other are having moving bed dryers. So fluidized bed dryer is one of the moving bed dryers. It is a kind of equipment which is very widely used in pharmaceutical industries in order to reduce the moisture content of pharmaceutical powders and granules. If we go and see the definition of drying, drying is a unit operation which leads to vaporization of the contents. More often than not, when we are preparing tablets or capsules, we come across granules. So, this equipment is very useful. It works on the principle of fluidization of feed particles, and in fluidization process, what is being done is that hot air is being introduced at high pressure through a perforated bed of solid particulate. In the later pictures, I will explain it through the diagrams. What we are doing here is that wet solids are lifted from the bottom and suspended in a stream of air. So the in order to achieve this fluidized state, it is very important that the force which is being applied to the particles, the powdered bed of solids, is sufficient enough to sustain them in the air. At the same time, it should not be large enough that the particles are going away in all directions. So in this bed dryer, we are accomplishing heat transfer by direct contact between the wet solid and hot gases, and vaporized liquid as it evaporates and leaves the contents through excellent heat and mass transfer. It is carried out by the drying gases which are collected in a cyclone separator. In order to explain the principle of fluidization, I will use a diagram of a toy which all of you might have seen. So, what we are supposed to do in this toy, we are supposed to blow through the mouth, and if the air pressure is too high, this ball will go in all directions. But if air pressure is proper, equal to the fractional drag of this ball will keep dancing in the air. So similar is the concept of fluidized bed dryer. All the particles, they are in a state of fluidization. That means they are dancing in the air, and this air is heated so that excellent heat and mass transfer is taking place between the particles and heated air. So there is transfer of heat from the air to the particulate system, and there is transfer of matter, that is moisture, from the particles to be dried to the air. So once this is done effectively, drying becomes easy. Here I present a diagram of vertical fluidized bed dryer. As you can see, there is a perforated bottom, and in this fluidized solids are, when there is no fluidization, that is, it is a perforated bed. And here, if you see to the right of the screen, inlet air is there, and this is fresh air which is being moved forward through a dust filter. This dust filter will stop all the unwanted dust and other particulate matter, and only pure air will pass through. After this, it comes in contact with the air heater, which can be heated either by steam or through electric means or hot water. This heated air is made to force through the perforations through the small holes. Basically, perforations are nothing but small holes. So these perforations are there, which are allowing the air to pass through this bed of solids. As I explained you in the previous diagram, each individual particle behaves like this ball, and when air is passing through them, initially they will move a little bit left or a little bit right, a little bit top or a little bit bottom, to allow the air to pass through. But once this is done, after that, the particles will achieve a fluidization state. Now, this fluidized solid bed can be removed. You can easily remove this fluidized solid bed, replace it with another such basket which is having perforations at the bottom. As you can see on the screen, product container is written, which is removable. Normally, for ease of removal, it is on wheels. On the top of it, filter bags are attached. These filter bags are attached so as to retain very fine particulate matter, and after this, air is entering an exhaust fan which is moving the air out. So the very fine particles are collected here, and they, some of the very fine are going through the exhaust air, which can be taken to the uh, next concept, that is uh, further clear from this diagram. As you can see, this is another representation of fluidized bed dryer. Fresh air is coming, it is passing through a filter, then a heater. There is a screen where the top of which there are fluidized bed of solids, and an exhaust fan is there which is making possible the movement of air in this direction. So here we have filter bags which retain the fine, and through the exhaust fan there is a connection to a cyclone separator. So end product would be a mixture of cyclone product and chamber product. Chamber product is the one which is retained is in this conical bottom portion. And if you see on the right of your screen, there is a path of particles which particles are following a path which is evident from the direction of the arrows. So turbulence can easily be seen. More is the turbulence, more easier is the transfer of heat and mass that can take place. And that way we can achieve excellent drying rates using this fluidized bed dryer. If I have to summarize, the fluidized bed dryer consists of these units. First is an air preparatory unit. As the name indicates, it prepares the air for further transfer into the main instrument. That is, it is equipped with dust filters or other sort of filters which can filter the air and stop the entry of unwanted materials. In air preparatory unit, there is also a heater which will heat the air, because ultimately the moisture removal has to be done through this heated air. Then B is product container, which will hold the dried product. C is the exhaust filter. I will explain each and every part in the next few slides. Next is exhaust blower. Then there is a control panel. After this, there is an air distribution plate, spray nozzle, and finally solution delivery. So, first of all, if I talk about apparatus, there are certain parameters which affect the working of the fluidized bed dryer. Now, many parameters are there. Let me first go to the previous slide. The product container is the one which contains the final product, the dried product. Exhaust filter is there, which tries to retain the fine particles, and exhaust blower is there, which is responsible for the movement of the air in a particular direction. There is a control panel. Now, next is air distribution plate. The purpose of this air distribution plate is it tries to recirculate part of the heated air and mixes it with the fresh air in order to achieve maximum heat efficiency. There is a spray nozzle and solution delivery, which is optional in certain cases. Now, moving further, there are certain parameters which need to be controlled in fluidized bed dryers so that we can get an improved operation efficiency and reproducibility. These parameters need to be controlled. We can categorize or classify into three main categories. One is apparatus parameters, those which are dependent or which are controlled by the equipment. Second is process parameters, which are controlled by the process. Third is product parameters, which are dependent on the product. I mean, neither the apparatus nor the process has got any influence on these product parameters. So we will discuss them one by one. First of all, apparatus or equipment parameters. So position of the air distribution plate. This air distribution plate, how and where it is placed, it influences the pattern of the fluidized bed dryer. Shape of the instrument is also important. We have studied the vertical one. In the next few slides, we will see that there is a horizontal equipment also. So the annular based design always gives a better product than the height of the nozzle, which plays a very important role when fluidized bed dryers are used as a coating machine. As you will appreciate, fluidized bed dryers can also be used as fluidized bed granulators. So the atomized solution should not get dried before it reaches the surface, that is, before it gets coated. So the choice of distributor which is used during and drying process, apart from ensuring uniform and stable fluidization, it also prevents poor fluidization quality of solids in certain regions in the fluidized bed dryers, especially when we talk about industrial fluidized bed dryers where the size is very high. It can be a problem that certain portions of the fluidized bed dryer do not get proper fluidization. So if we use a proper distributor, it will distribute and make uniform the fluidization process. Sometimes it also happens that the plugging of perforated holes takes place or plugging of distributor takes place. So this, if we are using a distributor, this will prevent the plugging of perforated holes. And it also prevents the solids from dropping into the wind box, which is located just beneath the fluidized bed. And you'll see that the pressure drops across the distributor. It should be high so that we can ensure a good and uniform fluidization. As I told you that we will be discussing horizontal fluidized bed dryer. The earlier one that we discussed was vertical fluidized bed dryer. This is a horizontal fluidized bed dryer. That was a batch process. This is a continuous process. As you see, feed is entering from the left hand side. There is a surge hopper, and on the bottom it is attached to a vibrator. The vibrator will make sure that the feed does not stop at one place and it keeps moving from left of your screen to the right of your screen. There is a perforated desk or perforated bottom through which the air can pass from left to right, and through these perforations the heated air is made to pass through the fluidized bed, and fluidization takes place. When fluidization is taking place, some of the very fine particles are carried away with the air in the direction of the arrows upwards, and ultimately they reach the cyclone separator, through which we get two products. One is air product, another is cyclone product. So cyclone product falls back along with the drying chamber product, and the final product is a mixture of the cyclone product and chamber product. The fines which are collected from cyclone separator can be fed back to the feed or can be used for other purposes. So this is a continuous type of fluidized bed dryer, very efficient in its operations. Further, we'll discuss the process oblique operating parameters. First of all, temperature, which is very important, because if we increase temperature, it leads to increased moisture diffusivity, and hence the drying rate is also increasing. And as a result, we get a very early drying, and drying time is reduced. Here, the nature of material plays an important role in choosing the operating temperature. Second is humidity. Faster drying is achieved when the moisture content of the inlet air is maintained at its minimum. This is because if you see the equation for heat transfer, Q is equal to UA delta T. So, higher the delta T is there, the temperature will effectively help us in achieving normal drying times or lesser drying time. Similarly, if the entering air is having high humidity, that it will not be able to carry more of moisture from the our product that is to be dried, or granules which are to be dried. So if air is unsaturated with moisture, so it will be having a capacity to absorb more and more moisture. If I talk about horizontal fluidized bed dryer, as the air moves from bottom to the top, there is not one opening, there are many openings. So air remains unsaturated. I'll click back to that picture. As air moves from left to right, it is entering through various holes in the bottom. So it remains unsaturated. Next is air flow rate or gas velocity. Higher the velocity, higher the drying rate. But we cannot increase the velocity beyond a certain point, because in order for fluidization to be possible, as I told you, the fractional drag on the particle should be equal to the air velocity that is coming from the bottom. Air is coming from bottom, it is forcing the particle upwards. Similarly, the gravity, because of the weight of the particle, is forcing the particle downwards. So when these two forces become equal, there will be a fluidization state that is being achieved. But if the downward drag force is higher, the particle will not move from its place. If the air velocity is higher, then this particle will move in all directions. So both the stages are not desirable. Next and last are the product parameters, moisture content of the feed. If the feed is too moist, then we cannot achieve very quick drying times. Then feed rate or the batch size. At what even if the moisture content of the feed is less, but if it is being fed at a higher speed, then the product characteristics will be influenced. The starting moisture of the feed and the desirable moisture content of the product both are important. Similarly, particle size, shape, and diameter. As you will appreciate, spherical particles are easy to fluidize as compared to needle shaped particles. So, this is also important in fluidized bed dryer. There are various types of fluidized bed dryers. Some are conventional, which can be batch fluidized bed dryers, or semi continuous fluidized bed dryers, or well mixed fluidized bed dryers, or plug flow fluidized bed dryers. So we can use, depending upon the feed, what type of feed we have, what is the end use of the product, how much percentage of fines can be tolerated in the product. That also dictates our choice of the fluidized bed dryer. Some of the modified fluidized bed dryers are listed here. These are hybrid fluidized bed dryers, pulsating fluidized bed dryers, fluidized bed dryer with immersed heat exchange, mechanically assisted. So I will not go into details of all these. Rather, this is more important. What happens? What is the mechanism of fluidization? First of all, you remember the diagram of the toy that I have shown you in the beginning of the slides. So at first, when air velocity is low, that is this point A in the diagram. Here we are plotting log of air velocity versus the pressure drop, delta P. Log of delta P we are plotting. So if I say that at the bottom of the fluidized bed, that is at the bottom of the perforations, there is a pressure, let us say P1, and at the top, when air is coming out, there is pressure P2. So delta P is the difference between P1 and P2. So at first, that is when we just start the fluidized bed dryer, air velocity is low, point A. So flow takes place between the particles without causing any disturbance. But as the velocity is increased, we reach a point B where gravity is equal to force of fluidization. That is, the fractional drag on the particle is equal to gravity. So after this, some rearrangement of particle occurs to offer least resistance, and we reach point C. Now, this is the stage when we can say that particles are dancing in the air. They are suspended in the air, and they can move in the all the directions. So at point D, the pressure drop through the bed decreases slightly because of the greater porosity of the pressure bed. And further, if you increase air velocity, the particles, they separate and move freely, and bed is called fluidized bed. This is the dancing state, and we want to achieve this dancing state. And if we go to further increase the velocity, this will then the particles will expand without appreciable change in pressure drop until we reach the point E. And at point E, this velocity of the particles is sufficient to top of the feed, to transport the particles to the top of the feed. Now this region D to E is important. Here fluidization is irregular. Much of the air that is flowing through in bubbles. So sometimes we are using boiling bed of particles to describe this D to E stage. Another important thing that we must note is to produce conditions of great turbulence, the particles should mix with each other. They should not with each other, they should mix with air. So if there is a surface of the particle, from top of the surface, moisture is going to the air, and air is coming in contact with the surface of the particle. So it is giving its heat. As a result, that moisture is evaporated, and it is because air is moving, So air carries that moisture away from the drying site, that is the surface of the particle. So if hot air is used in turbulent conditions, it leads to high heat and mass transfer coefficients, and the fluidized bed technique is therefore a technique of rapid drying. I will come now to advantages of fluidized bed dryer, because as we just discussed, there is efficient heat and mass transfer. So this gives high heat transfer coefficients, high drying rates. So moisture is removed quickly. So drying times are shorter than, as you would say, compared to a tray dryer, or in fact even rotary dryer. Drying times are lesser. Heat challenge to the thermolabile materials is minimized. If there is a temperature sensitive material, because drying time is less, so it is not exposed to high heat for a longer period of time. The fluidized state of bed ensures that the drying occurs, as I told you, from the surface of the particles and from all the directions, 360-degree, because particles are dancing in the air. They are in a fluidized state. So, from all the directions, heat and mass transfer can take place. So, most of the drying will be at constant rate. And if you remember the rate of drying curve, the falling rate period will be very short. Continuing with the advantages, the temperature of a fluidized bed dryer is uniform and it can be easily controlled. And the turbulence that is present in a fluidized bed, it causes some attrition to the surface of the granule. So this produces a more spherical particles. The free movement of individual particle eliminates the risk of soluble materials migrating. Solvent migration is observed especially in static bed dryers, where from the surface solvent evaporates, leaving a hole in the center of the bed of the solids. So that gives a very uh, poor look to the product. But here, the final product will be spherical and uniform product. High thermal efficiency is achieved. So that means we can recirculate part of the heated air to achieve high thermal efficiency. There is lower capital and maintenance cost, reduced contact time for drying, therefore thermolabile materials can easily be used, and this equipment is easy to control. However, there are certain disadvantages also. There is a high pressure drop from top to bottom as a result uh, of the need to suspend the entire bed in gas, which equally leads to high energy consumption. It also requires increased gas handling because of extensive recirculation of exhaust gases for high thermal efficiency operation. Now, if the feed is too wet, this fluidization can be poor and flexibility is compromised. So, we need to be careful, specifically with poor with that feed which is having poor fluidization. Sometimes it is said that this is not the best choice when you are handling organic solvents which need to be removed, because there is a problem with the flammability of the products. Sometimes, if the flammability limits are exceeded, then explosion can also take place. Lastly, the fine particles may become entrained in the fluidized air, and they should be collected by bag filters. So I would say that even if the bag filters are retaining 10 to 20% of the total feed, this can be a substantial loss, specifically if the product is very costly. In case of very potent products, this loss can be substantial. So this needs to be carefully chosen in case of such products. I will conclude with industrial applications of fluidized bed dryer. As I told you, it can be used in a number of industries, chemical industries, pharmaceutical. I will focus on granulation systems can be combined with fluidized bed dryers. So you can achieve all these steps in one equipment, that is drying, mixing, granulation, finishing and cooling operations all are completed on the same process. Not only in pharmaceutical, it is being used in food, dairy, metallurgical, dyes, and other process industries. These are some of the references. Thank you so much. This is the end of my lecture. I hope I was able to explain the concept in a detailed manner.
Thank you, sir. Thank you, sir, for your very informative lecture in very easy to understandable way for the pharmacy students. This will definitely useful for the listeners and viewers of the pharmacy fields. And I request to all the listeners and viewers, please put your queries and questions in chat box if any, and we will reply you soon. So before closing the session, once again, I heartily thanks to respected Viney Chawla sir for accepting our invitation and sharing your experiences for the budding pharma professionals. Thank you, sir, and thank you to all.
Thank you so much.
Thank you, Vinay sir.
Thank you, sir. Thank you.
The topic which you select, sir, that was extraordinary because when we are entering in a pharmaceutical